Hello there. Hope you're doing well. I'm going to go ahead and take a minute and go over the input output tables in context. So let's take a minute and do so. My brother and I are going to start a savings account to earn enough money to buy a car. We will have enough money to buy the car we want in 15 months if we save $300 per month. Below is a function that models the relationship between the number of months, M, that have passed and the amount the brothers have saved, S of M. Okay, so we know we have input variables, right? First of all, the name of this function is S for savings. So the name is S. The input variable is M, which is there, and it's also in the rule right there. So the savings based on the number of months is equal to this, where M is the number of months you've been saving. So what is the name of the function? That is S. Name the input variable. That is M. What is the function rule? $300 for every month you're saving money. Complete the input-output table using 5 inputs and outputs. So I know to complete the table, I'm going to use my function, which models the amount of money the brothers will have. So if I have 0 months that I've been saving, so this is the day we start the savings account, at 0 months, I have $300. So the day we start it is 0 months. Well, 1 month later, at 0 months, I have $0. And then after the first month, I'm going to have 300 times 1, and 300 times 1 is going to be 300. So after the first month of savings, I'll have 300. After 5 months, S of 5 is going to equal 300 times 5. So notice I'm just going to my function right here, and I'm inputting these input values in. M is the inputs, S of M is the outputs, and that gives me 1,500. So after 5 months, there will be $1,500 in the account. S of 10 is going to equal 300 times 10. So after 10 months, we're going to have $3,000 in the account. And then the last input that we have here is 15. So I'm going to go ahead and enter 15, and that's going to give me $4,500. Okay, so those are the inputs and outputs for the brothers saving for a car. How much money did the brothers have saved after 5 months? After 5 months, they had $1,500. Notice how I'm using proper unit of measurement when I'm answering these individual questions. How much money did the brothers have saved after 12 months? Well, I'm going to have to figure that out. But what I know is that every month we save 300, and if I put the number of months in for the input variable M, that will give me the output amount that they're asking me. So after 12 months, there will be $3,600 in the account. How many months did it take for the brothers to save 3,000? Well, I'm going to go up to my table, and I'm going to notice right here we had a savings of 3,000, and that occurred after 10 months. Again, unit of measurements on these individual questions. How many months did it take for the brothers to save $2,100? Well, that's interesting because $2,100 is not on the table. So I'm going to have to find it. So this is what I know. This is my output, the amount of money saved. So if this is asking me to substitute the amount of money saved into this function and solve it for M, how many months? That's M. So I'm going to go up here, and in my output, I'm going to put 2,100, and I'm going to set that equal to 300M. Now I'm going to solve that for M. To solve that for M, I just divide both sides by 300, and I get 7. So that means 7 months. I'm going to check that answer real quick, because if it's correct, I should be able to substitute 7 in the input value and get that output of 2,100. And I do. So we're good. How much did the brothers save to buy their car? Well, they only saved for 15 months. That's what we know. So after 15 months, they had $4,500. What are the minimum and maximum values of the input X? Well, the minimum is when they had 0 months of savings. The maximum is when they had 15 months of savings. So the minimum is the lowest value and 15 is the highest value. Maximum is the highest value. Okay, let's keep going. Number 2, in 1980, Joan bought a Chevy Camaro for $12,000. She sold it in 2020. The car depreciated at a rate of 5% annually. Depreciated means it lost value. Below is a function that models the relationship between the number of years, X, so X represents the number of years that have passed since Joan bought the car, and the value of the Camaro, C of X. So again, we really got to be good at this. C of X is the value of the Camaro, and X right here is the number of years that Joan has owned the Camaro. All right, so number of years that we've owned it and value. So value and number of years. All right, so make sure we're looking for those prompts. What is the name of that function? Well, that's C right there. Input variable X. What is the function rule? 12,000 times 0.95. I know an open parenthesis next to a number means multiplication, and a power of X. Now we're going to have to make a table of values. So I'm going to go down here, and I'm going to input those one at a time. But actually, I'm going to do something else here. I'll input the first one, but then I'm going to show you something else. So I'm going to say 12,000, 0.95, exponent of 0, and I get 12,000. So input 0, output 12,000. Actually, I'm just going to keep going on this. Now I'm going to insert a 10. 7185. I'm going to round this up to 7185. Actually, I'm going to round to the nearest cent because that's what money is. 7184.84. Notice how it's decreasing in value after 20 years. So now I'm going to continue filling in that table. Enter 430183. And I'll show you how I'm doing this again. So let's say I'm going to enter it for 30. I'm going to put in the initial amount. I'm going to go ahead and clear all that. I'm going to multiply it by 0.95. And then I'm going to raise it to a power of 30. Remember that power button is right here on the calculator. 30. Enter. 2575.6. I'm going to truncate, which means I'm just going to cut it off. So 0.66. 2575.66. And then I'm going to go ahead and enter that again. 0.95, exponent of 40, 1542.14. Okay, how much was the Camaro worth after 10 years? Well, dollar symbol, because now we're answering individual questions. How much was the Camaro worth after 25 years? I'm going to have to calculate that. So 12, 1, 2, 3, because that did not show up on my table. So I'm just going to input that number of years, 25, in for X. And that's going to give me 3328.67. How much did Joan sell the Camaro for in 2020? Well, she bought it in 1980 and sold it in 2020. So that means she sold it after 40 years. So that's how much Joan sold it for. If your math teacher won lottery and bought you any car truck, what would it be? Well, you let me know what that answer is, okay? What are the minimum and maximum values of the output? All right, that's the cost. The minimum is, notice it happens to be the end point, right? Because it depreciated. And actually, you don't need the dollar symbol here because we're not answering an individual question like problems E through G. And then the maximum is, well, it looks like the maximum was actually the amount that Joan bought it for, 12,000. Okay, let's keep going. Miguel kicked a soccer ball from the end goal line. The flight of the ball can be modeled by the given equation. That's awesome. All right, so X is time. So notice how they tell me X is time. So time in seconds. And H of X is the height of the ball in feet off the ground. All right, so that's important. That's time in seconds. And that is the height of the ball after X seconds. The name of that function is H. The input variable is X. The function rule is negative 3x squared plus 15x. Let's go ahead and fill in this table. So I'm going to do H of X equals negative 3x squared plus 15x. And I'm going to find H of 0. Actually, I know that H of 0 is going to be 0 because 0 squared is 0 times that, and 0 plus 0 is 0. So I'm good with that. H of 1. That, by the way, means at time 0, the ball was still on the ground, right? This is height off ground. And this is time in seconds after the ball was kicked, right? As soon as the ball is kicked, the clock starts. And I'm going to go ahead and enter that in like that. I'm going to go here. And I'm going to go negative 3. Make sure you hit that negative key. That's important. 1 squared, boom, plus 15 times 1. Enter, and I get 12. So after 1 second, it was 12 feet off the ground. Let's do H of 2. So there's that. I'm going to go ahead and go here. I'm going to do negative 3, open parentheses, 2 squared. I'm going to close that, plus 15 times 2. Enter, 18 feet off the ground. So after 2 seconds, it was 18 feet off the ground. Let's find H of 3. Again, I'm going to just enter that into my calculator. Negative 3, 3 squared plus 15 times 3. Let's see what we get. Oh, it's 18 again. That must mean it leveled out and it's going to start coming down now, huh? Let's go ahead and do H of 4. And put that in your calculator. Sorry, I'll leave that visible. So negative 3, 4 squared plus 15 times 4. That's not a 4. There's a 4. 12. Oh, we're coming back down. And I can already tell that this is going to go back to 0. By the way, if it goes back to 0, that means it landed on the ground, right? You're 0 feet off the ground. So it landed back on the ground. So it started on the ground, went up in the air, up in the air, up in the air, up in the air, and boom. Okay, how high was the ball off the ground after 2 seconds? Well, after 2 seconds, the ball was 18 feet. This is unit of measurement is feet. So 18 feet. Make sure you use those unit of measurements on these ones. 3.5 seconds. So that's not on the table, but I know it's going to be between 18 and 12 feet. If not, I made a mistake. Enter. 15.75 feet. And notice that is between 15 and 12. So 15.75 feet. How many seconds did it take for the ball to reach a height of 18 feet? Well, that happened twice. It happened at 2 seconds on the way up, and then it happened again at 3 seconds on the way down. So 2 seconds and 3 seconds. How many seconds was the ball in the air before it hit the ground? Well, I know it hit the ground, boom, right there, because the height off the ground is 0. So 5, and we're talking about seconds. What intervals of the graph are increasing and decreasing? Okay, so increasing is where it's going up. So notice from, and we're looking at increasing on the Y, the output, but the interval is going to be on the input in time. So notice it's increasing from there to there. Now at 2.5 seconds, it went a little bit higher than 18, but let's pretend like we're not sure about that. Okay, we'll learn that later. So it increases from 0 to 2 seconds. And then notice from 18 to 0, it decreases. So it decreases from 3 to 5 seconds. All right, let's move on. I'm going to go ahead and do these graphs on a separate video. So be aware of that, please.